How can narrative gameplay be utilized for a higher level of interactivity within a multi-touch interface using natural human gestures? The Labyrinth project is an interactive multi-touch game based on the ancient Greek myth of Theseus and the Minotaur. The user will play as Theseus and will make his way through the labyrinth, crossing different territories and overcoming different challenges. Over the course of the year, we've had various delays in production and have also made major strides. As a starting point, in our first proposal, we proposed 6 games that were specific and factual to the original mythic story of Theseus. We designed the gameplay based on the narrative and did not take the affordances of a table, touch surface, and its gestures into consideration. This proved to be fatal as the execution didn't coincide with the level of programming. The next major setback we had was the opted use of Box 2D physics engine in our gameplay. Box 2D is a rich 2D rigid body simulation library that makes objects move in realistic ways. Its functionality was crucial for our first game. The setback we had with this was the syntax and modified library, which is ideal for a single game but cumbersome when used within a series of games. Its outcomes just couldn't be predicted. This modified library, in combination with how much time was spent on it, proved to be ineffective as it held up the progression of the other games and overall production schedule. Another issue that constantly affected our production and still affects our production is the illumination of the table. We are currently using 4 Wisecom LED infrared illuminators to irradiate the projection surface. These 4 provide enough lighting for the camera to capture at a low frame rate. Our games, together with the table's tracking abilities, requires a high frame rate in order to be efficient and effective in executing gameplay functions. As a response to the table problems, we added 2 infrared LED light bars to cover dark spots, and additionally we've ordered 4 more LED light bars. We also redesigned all our 6 games using the appropriate gestures that afford tables and touch surfaces, while still maintaining the core elements of the narrative. Throughout the game, the player will still have to pass a total of 6 gates in order to complete the game and eventually kill the Minotaur. The player's level of interaction and objectives changes as he navigates further into the different games and deeper into the labyrinth, which will be represented in the gameplay. The first gate begins with Theseus being oriented with his new environment. The gameplay requires the user to identify with similar objects to get rid of some others. Theseus has to decide what good omens he needs to take on his journey, as this would help him to be in good standing with the gods. The second gate has him trying to scale and fit certain ornaments within a required amount of time. The third gate's emphasis is on memory, as Theseus has to eliminate matching cards with different clues to reveal an important asset to his journey. His timing has to be crucial. Theseus then has to overcome his first enemy by being strategic, dropping certain artifacts in a cave. After this gate, Theseus will now enter the 5th gate, where he'll be close to the Minotaur's lair. This game will require him to put the Minotaur to sleep by playing a series of melody sequences. His timing has to be fast enough in order to put the beast to sleep. The final gate requires him to save himself from the crumbling labyrinth's walls by shooting them down. He may possibly battle the Minotaur in this game. The multi-touch interface makes the user handling very intuitive. Its manipulation can be used in different ways and for several functions. The Labyrinth game, together with the table, encourages discovery without instruction and accidental learning through physical interaction. We are developing our games in Adobe Flash using a combination of 2EO messages sent from CCV. Community Core Vision software is a solution for machine sensing. It takes the video input screen and outputs it as tracking data. The 2EO application is an event-based protocol that reports when fingers press, release, or drag on the table. A PS3i camera with a wide-angle IR bandpass filter is also being used to capture the reflected infrared blobs, which are sent and processed using CCV, which takes the data and uses it when connecting and communicating with Flash, which is the primary game engine. We are using pure data to execute our audio files. The Flash server abstraction allows for bidirectional communication between pure data and Flash, and is what we've incorporated to address all the game's audio. For the last phase of production, we plan to make the games better by adding additional features that enhance the level of interactivity within each game. We're also going to add all audio and their features throughout the game. And lastly, we'll address the table by adding necessary lighting and also painting and adding additional graphics so that it matches its content aesthetically.